This question says that a message signal of frequency 100 MHz and the peak voltage 100 volt is used to execute amplitude modulation on a carrier wave of frequency 300 GHz and the peak voltage 400 volt. So here we need to find out the modulation index and the difference between the two sideband of frequency R. So this question is asking about to find out the modulation index and the sideband, the difference between the two sideband of the frequency. So the frequency of message signal is given. Let's message signal is given, which is FM 100 megahertz, and frequency of carrier signal is given, which is 300 gigahertz, and the amplitude of voltage is given of, say it is AM, of message signal is 100 volt, and amplitude of voltage of carrier signal is given 400 volt. So we know that the modulation index is given AM upon AC, that is voltage or the amplitude of message signal upon amplitude of voltage of carrier signal. So putting this value, that is AM 100 upon AC 400, it's come to be 1 upon 4, which is equal to 0.25. So we have find the modulation index, that is MI, which is always less than 1. So 0.25 is less than 1. So modulation index we have find 0.25. Now we need to find out then the next part, it is the sideband, the difference between two sideband. So when there when the when there is execution of some amplitude, execution of some message is given, so there always produces two frequencies, two band of frequencies. One is upper band frequency, which is FC, that is frequency of carrier wave, plus frequency of message signal, and the another is lower band frequency, which is equal to frequency of carrier wave minus frequency of message signal. So if we differentiate this, that is FC plus FM minus FC minus FM, we will get FC plus FM minus of FC plus FM. So from here FC and FC will get cancel out, and we will get 2 times of message signal, and frequency of message signal is given, which is 10 to power 8 hertz. So 2 into 10 to power 8 hertz. So we have the modulus index Mi, which is 0.25. We have found the modulus index Mi 0.25, and the difference between the sideband, which is 2 into 10 to power 8 hertz. So let's see which option it matches. So option C, 0.25 modulus index and 2 into 10 to power 8 hertz. Thank you. Hope you guys understand. So in this question, the question says that 50 watt per meter square energy density of sunlight normally incident on a surface. So a light. So this is the surface, and the light is normally incident on it, making an angle 90 degree. Now the further question, on a solar panel, some part of incident light, that is 25% is reflected from the surface and the rest is absorbed. 25% is reflected and the rest is 75% is absorbed the force exerted on 1 meter square surface will be, so we need to find out the force exerted by the incident light on the surface of 1 meter square. So intensity it is given here, I equal to 50 watt per meter square. This is the intensity of light, and we know that if the surface is completely reflected, then the force exerted on it is given by light of intensity I when incident 90 degree is given by 2I upon C. But here it is given it is only 25% of intensity is reflected, so 25% of it, 25 by 100, force exerted by reflected light is 2I by C into 25 by 100. Now force exerted by absorbed light is given by F equal to I by C, but here 75% of it is absorbed, so 75% of this intensity is force exerted by the absorbed light. Now if we sum this force, we will get the total force. So total force F total is equal to this force, and this force, reflecting force and absorbed force, which is 2I by C into 25 by 100 plus I by C into 75 by 100. Taking I by C into common, I by C, so it will be 25 into 2, 50 by 100 plus 75 by 100. Now on further calculation, 75 plus 50 is 125, I by C into 125 by 100, and intensity is given, I is 50 watt per meter square, and speed of light is also given. See the speed of light, which is 3 into 10 to power 8 meter per second. So putting the value to get the F total, so F equal to 50 by 3 into 10 to power 8 into 50 into 120 by 100. So we will get 625 into 10 to power 9 minus 9 by 3. On dividing this, we will approximately get the value 20 into 10 to power minus 8 Newton. So this is the force exerted by the light, which is 25% reflected and 75% absorbed. So let's see which option it matches. 20 into 10 to power minus 8. So it is option B. So option B is the correct. Thank you.
Welcome to DoubtNut. As in the given question, we can see a signal, that is message signal A cos omega t, is transmitted using the carrier signal, carrier wave. Find the correct amplitude of the modulated signal. The question is asking about the amplitude of the modulated signal. So in this question, the message signal is equal to A cos omega t. A cos omega t. And the carrier wave is equal to V naught sine omega naught t. So the carrier wave actually carries the message signal, and thus when the message signal is sent through any carrier wave, it basically message signal is added in the amplitude of the carrier wave. So we can see here the final signal which will be sent with the carrier wave. So the final signal will be modulated signal, and this modulated signal will be equal to like this one, V naught carrier wave plus A cos omega t message signal, and in this sine omega naught t, only in the amplitude portion the message signal is added. So this will be the modulated signal. So we can see that when we will multiply, it will be equal to V naught sine of omega naught t and plus a cos of omega t sine of omega naught t. And this is basically nothing but when we will multiply by 2 and divided by 2, so this portion 2 sine A cos B will be like the trigonometric formula, and it will be equal to, this will be as it is, V naught sine of omega naught t, and this 2 will be divided with this one, A by 2, and 2 sine A cos B will be equal to sine A plus B. It means omega naught plus omega into t. 2 sine A cos B will be equal to sine A plus B plus sine A minus B plus sine of A minus B. Omega naught t minus omega t. So this will be the answer. And basically we can see that it will be further calculated V naught sine of omega naught t plus A by 2 sine of omega plus omega naught t, omega naught plus omega t plus sine of omega naught minus omega into t. So we can match from the answer, and this will be our amplitude. Okay, this will be our amplitude. So finally we can see this will be our amplitude, and this will be the answer. Okay, thank you so much.